So we looked at the proof for part 1, and I said the part 2 is just reverse, exact same argument, just on the divergent side. The last one there, the fact that this test is inconclusive for rho equal 1, is easy to show. All I have to do is show you an example of a convergent series whose rho is 1 and a divergent series whose rho is 1. And so then we can see that there's no way you can make a decision when rho is 1 because it can come out either way. And really the best example for this is p-series. So if we look at something like, say, 1 over n, we know that to be a divergent p-series, right? This is divergent p-series. P is 1, which is less than or equal to 1. So what happens if we do a ratio test on that? We can. It's legit to try because the terms need to be positive. So first of all, the terms are positive. So what happens if I take the limit there? Remember, ratio test, you want to take this thing evaluated at n plus 1, this thing just evaluated at n, look at that ratio. Divide by n on top and bottom. And that limit's just 1. So if you do the ratio test on that p-series, you get 1. But what if we did a convergent p-series? 1 over n squared. Again, we can try ratio test because the terms are all positive. But what happens if I take the limit as n goes to infinity of this evaluated at n plus 1, so 1 over n plus 1 squared. So now I'll flip that, make it proper fraction. Now I'm going to divide top and bottom by n squared, as we always do with ratio tests. Just divide by that highest degree term, and these are squared. It's the highest on both there. And I was a little brief with the algebra here, but there's 2 of these, right? There's an n plus 1 and an n plus 1. So one of my n's goes into one of them, 1 to the other. So that's why that ends up being 1 plus 1 over n there. And that limit is 1. So right there we see that this test must be inconclusive when you get 1, because here's an example of something which I should have probably stated here at the beginning. This is a convergent p-series, right? P is 2, which is bigger than 1. Here's a convergent p-series, but the rho comes out to be 1. Here's a divergent p-series, but the rho comes out to be 1. So we must not be able to make a decision. If I didn't know the behavior of either one of these, they have opposite behaviors and they're given the same rho. So that proves that the test is inconclusive when rho is 1. Now, one thing to note from this is typically, if you try to do the ratio test and you get a rho of 1, it probably means that what you have is a p-series or really needs to be compared with a p-series via LCT or DCT. So all is not lost. If you end up with a 1, the first thought you should have is, oh, am I really dealing with a p-series or something similar to a p-series, so that I should really be doing DCT or LCT. So that would be my first thought if it comes out inconclusive like this.